Hello, I'm Arda Aykanat. I'm a mechanical engineering major in Bilkent University. Today I'm gonna perform an experiment about the springs and energy conservation. For this experiment, we need a ruler, three objects with different masses, two different springs, one for compression and one for elongation, and air table. For first part, we need a spring and three different masses. I'm gonna attach the mass like this, and mass will pull the spring down, and we will measure the elongation of the spring. With this data, thankful to Hooke's law, we can calculate the spring constant of this spring. For part B, we need a spring like compressor and an air table. I will push the first pedal and it will create a frictionless plane. And when I press the second button, it will create dust in an equal time interval. So we will be able to calculate the velocity of particles. So I'm gonna compress the spring and okay, let's see the dots. As you can see, it created dust. With this, we can calculate the kinetic energy of the pack, and we will see if it's equal to potential energy of the spring. We know the spring constant of this. We know the elongation, so we will be able to calculate it. The results of the first part are as shown in the table. It is obvious that there is a direct proportion between the force and the amount of the extension. The real constant of the spring was 20 newtons per meter. The calculations we made using Hooke's law were also close to the real value. This shows that the first part was successful. For the second part, we used two tables. In the upper table, we measured the average speed of the disk, while in the lower table, we calculated and compared the kinetic and potential energy. We repeated this process by compressing the spring by 1, 2, and 3 centimeters. The results were a bit unexpected. In theory, energy should be conserved, but in our test, we encountered energy losses 30 to 50%. This may be due to improper throwing of the disk or inadequate measurement tools. As a result, it was observed that there was a direct proportion between the force applied to the spring and the extension distance. It was learned that the spring constant could be calculated accurately using this data and Hooke's law. It was observed that 100% energy conservation is impossible in real life. Despite this, springs exhibit good performance in terms of energy efficiency at a level that can be used in daily life.